Welcome back, Pre-Calculus. I am happy to have you for our last video on exponential functions. Oh, sorry, I turned my iPad. Oh, stupid teacher tricks. All right, I shouldn't say that. I don't want you guys to call yourselves stupid. I'm not stupid either. We all make mistakes. So we're going to talk in this video about continuous growth or decay. So we talked in the last video about interest that compounds, which means that we add in the interest that we're earning back into the amount of money so often, every couple times a year, right? But this is talking about, what if I'm continuously compounding my interest, right? What if every time my loan debt, gets another 2% interest, I immediately add that interest back into my principal value and calculate the next amount of debt. So what we need for continuous growth or decay is we actually need an irrational number called E. So I'm going to tell you guys about the irrational number called E, and then we'll do these two examples here using E, and that's going to help us. All right? So let's start off just by talking about E. So E is an irrational number. And it's an irrational number like pi. And here's actually how you calculate E. This is kind of, I think, interesting to me. It's a pattern that comes up a lot in nature. If you take 1 and you take some fraction 1 over n, and you raise that to the nth power. So you can plug in different numbers for n, and you'll get different values, right? But what we want to do is we actually want n to increase forever. We want n to approach infinity. As n approaches infinity, then we get the number E. We get the number E. And if you want to know more about that, we're going to talk more about that in class. I think it's actually kind of interesting. And you can also find E on most calculators. All right, you can find E on most calculators. And so we're going to use this number, this irrational number E. We're going to use that fairly often when we talk about continuous growth or decay. So here is the formula for continuous growth, continuous growth or decay. So I have a function, a of t is equal to a e to the rt. And here, a is our initial value. So we have our function a, which is the initial value of whatever we're dealing with. And we have E now is taking the place of our base, of our growth factor. Isn't that interesting that we can have one number taking the place of that growth factor that we've been using so far? But we also have something interesting happening in the exponent that's different than what we've seen so far. So we have this R. This R is actually going to be our growth or decay rate. And hopefully you're guessing now, you're just shouting out at your computer screen, Sarah, T must be time. And you'd be right. T is elapsed time. And this is a formula for continuous growth or decay. So you're going to need to get your calculators out for this one. So get your calculators ready, because we're going to need it, and I want to make sure that you guys can follow along. I'm also getting my calculator out. My calculator is, of course, Desmos. Desmos has a free graphing calculator. It also has a free scientific calculator, if you like. It has a free scientific calculator where you can find values of E as well. Okay, so let's do our first example. This example here, where we have a person investing $100,000, must be nice, right? At a nominal 12% interest per year, compounded continuously. So let me show you guys something. This phrase here, compounded continuously, that's how you know that you need this formula. When you see that phrase, compounded continuously, you know automatically that you need that E, that you need that factor there. So if we're looking at the different pieces of this problem, I see my initial investment is 100,000. So that'll be my initial value. I see my interest rate is 12%. So that'll go here for my growth rate. And remember, I'll write that as a decimal. I'm not going to leave that as 12%. I'll write that as a decimal. And we want to know what the value of this investment is in 30 years. So that means I'm going to plug in 30 for my value of T here. And then I'm going to just plug all of this right into my calculator. And it's going to give me the answer for how much money this person is going to make in 30 years. I would say this person because, like, couldn't be me. I don't have $100,000 to invest. Would be nice, though. Would totally be nice. So let's see what we have here. We decided our A of T. We're going to plug in 30 for that. We're trying to find out what's our amount. So our initial value, our initial investment was $100,000. I say our initial investment now. Wouldn't it be nice? Our rate was 12%. And if you write that as a decimal, that's 0.12. And our time is 30 years, so we'll multiply that by 30. So in your calculator, what you're going to type in is 100,000 times E raised to the 0.12 times 30. I'm going to type that right into my calculator right now. If you've typed that all in correctly, you should see that this person's making a boatload of cash. Wow. That's a lot of money. So it turns out continuously compounding interest is a pretty good deal. This is an example of continuous growth. Let's do the one about decay. So we